there's lots of these organizations which create websites in today's date, web portals. So once you go and ask them, okay, fine, my particular website could not be accessed by a particular user at a particular time, they would want some kind of information from the IT department, and presume the IT department gives them a list of login times, a list of times um, which were actually recorded by the users, saying that it took me, say, these many seconds to log on to your website, or this took me, accessing a particular uh, page on your website took so many seconds from you, or things to that effect. Presume this information is logged into a particular Excel sheet, and that Excel sheet is given to that particular organization. Now, how could they go ahead and evaluate as to whether what is the acceptable time limits for such a login, and further on, how would they go and classify, saying that this is the accepted standard, SLA, the standardized SLA. Now, presume this is a normal distribution, um, and you have gone ahead and accessed the website using a smartphone, using different operating systems, using lots of other, you know, uh, methods that you can. You have gone ahead and accessed the website on the servers which are housed, or you've gone ahead and accessed the website on the cloud on which it has been hosted, and the average time or the mean time that you have for the access of the website is 4.237 seconds, right? And the standard deviation of that normal distribution is 1.3, that is 1.3 seconds. 1 second, 0.3. Now what you basically want to know is, within less than 2 seconds, how many users, or what is the probability at such speeds, that how many users would be able to go ahead and access your website out of that entire list. So the probability of user, and this is a normal distribution, so under a normal distribution, under the area covered under normal distribution, uh, the sum of probabilities is 1 always. So that within that 1, how many users would be able to access less than, within less than 2 seconds. So if you go ahead and input that figure over here, and the formula which we are using, so this is basically the standardized formula, which is converting the X scale, that is the seconds scale, into the standardized Z value. And then you have the formula which is norm dist. So the norm dist within Excel 2010, which will go ahead and calculate the probability of the users who will be able to access the particular website within a time frame of, say, zero point 0.5 seconds, or 1 second, or 1.5 seconds, or 2 seconds. So anything below the value of 2 seconds, this is the probability, that is 0.0426. Similarly, you would want to know as to how many users would be taking more than 1.8 seconds to access that website, or download that particular page, or that page refreshing on their smartphone. So whatever criteria that you have, that you already shared with that website developer, that organization which is providing your cloud or maintaining your servers, your IT department, whichever way. So then again they go and, so that is the X value, which is in seconds, 1.8 and above. So how many users would be accessing the website according to this normal distribution in more than 1.8 seconds, which is, say, 1.9 seconds, and 2 seconds of course, or 2.1, 2.2, right up to, say, whatever is the maximum limit of this normal distribution, the mean being 4.237. Let's see what could be the maximum limit. We'll come to that also. The maximum limit should be somewhere about 7.26 seconds. So beyond 7.26 seconds, we have not recorded any users spending more than, say maybe around 7.30 seconds, not beyond that. So the maximum could be 7 point this thing, because what I have over here is 99% as the cumulative percentage. Now I'll come to that later. So coming back to this, uh, the probability is that 0.9696 users will go ahead and access that particular website in more than 1.8 seconds. So that is one. Then you want to find out a particular range. You want to understand that within the timing of say 1.5 seconds to 2.5 seconds, which is 1.5, 1.6, 1.7, 1.8, 9, 10, 2, 2.1, 2.3, right up to 2.5. Within this particular range, how many users will fall? So what is the probability over there? The range will be calculated in this manner, that you take out the probability, or you compute or you solve for the probability of 1.5 seconds, which comes out to be 0.0176, and then you solve for the probability of 2.5, and you go ahead and subtract the sum of these two numbers, the sum of these two probabilities. You go ahead and subtract from 1. Why do you subtract from 1? Because 1 is the total possible, the sum of all probabilities under the normal distribution is 1. So like you see over here in the formula, it says 1 minus B32, which is 0.9268792, which is the sum of these two probabilities. It has been subtracted from 1. So 0.0731, which is 0.73% individuals in that entire data set that you have collected, and basis that particular data set, again going forward. So it's more of a predictive inferential prediction that is there, that so many individuals will be able to access that particular website. So that's the probability. And if you look at this particular figure over here, we are trying to find the z value and the x value by inputting a cumulative percentage over here. So the cumulative percentage is what we are providing. So if you were to give 99% over here, then the x value for that is 7.26. Let me try with 99.99%. Sorry. Let me try with 99.99% and see as to what I get. Okay, so I'm getting a probability which is much higher, or sorry, the x value which is much higher. So which means my maximum possible login time, the slowest login time, so to say, is around 9 seconds, 9.07 seconds. And let me go to 1% and see what do I get. So my lowest possible would be 0.001. Let me see, what is this? Okay, so somewhere about 0.21 seconds would probably be my lowest login time. So that's how we get to the cumulative percentages. And presume we were to look at again, for a particular percentage, we want to understand that under the normal distribution, 95% users would fall under what values of x. Between what values of x would they fall? If this is the term which is being used is symmetrically distributed around the mean. So why symmetrically distributed around the mean? Because in the normal distribution, the mean and the median are the same, and there is a certain symmetry which is formed. So it's a symmetrical distribution. It is not something which is right skewed or left skewed to a great extent, and that's the reason we call it the normal distribution. So within the normal distribution, if you want to understand, 95% of your data points would fall between what values on the x scale, then the lowest x scale value that you need to look at is 1.689, and the highest value that you need to look at is 6.785. So within this, you'll find 95% of the measures that you have actually gone ahead and measured the measures that you noted down.